morning, YouTube. I'm gonna give a quick discussion about surge protectors and electrical management systems for your RV and demonstrate installing a hardwired one here on my Class C. So let's get started. All right, so let's talk surge protectors. I'm sure when you think of surge protectors, you think of those 6 outlet type plugs that you might have your computer at home plugged into or your TV at home. Their goal is to protect your equipment if there's a unanticipated surge of power due to some issue with the power grid, a lightning storm or whatnot. Same principle for RVs. Generally speaking, most of them do not come with any protection from these type of events. I know mine doesn't, and it was a fairly expensive Class C. Some of the Class A's that I've looked at, especially the really high dollar diesel pushers and whatnot, some of them will come with some form of protection. So it's best to first assess what kind of protection your RV has. If it has none, you may want to consider adding some measure of protection. You can go as cheap as $70 or so to get just a basic surge protector for them. Just keep in mind that only protects you from a surge of power. When I first bought my RV, I picked up this EMS-PT30C, which is a portable electrical management system, which is basically a surge protector plus, which I like to call it, where it has some additional features to help protect your investment. And to be honest, it saved me potentially some injury and some severe damage to some of my systems, and I'll explain here in a few minutes. So this is the system right here. You can see it. It's got a 30 amp plug on one end, a 30 amp plug right here for your cord coming from your RV to plug into. You'll see on the upper right, let's see if we can bring it in a little closer, there's basically 11 states, or what they call error codes, that can be in. So E0 just means you're in a normal condition, which means everything is what you would expect. And then you have some other issues. You could have reverse polarity. So what if the plug was wired backwards at the campground? You know, if the electricity came in backwards, you'll fried some stuff in a really hurry, which is not good. So having that measure of protection. So if you plug this in and it detects that it's wired wrong, it's not going to turn the power onto your RV. So you've protected your investment. Open ground, error code 2. I've had this one before. Went to a campground site once, plugged in my unit, and it was flashing E2 and it wouldn't turn it on. Had I not had one of these, the situation would have been that the ground circuits all within the RV would not had a place to go back to. You could have run into a situation where you got shocked. That would have been pretty bad. And it also allowed me to go back to the front office and say, hey, you know, there's something wrong with your plug. They brought a technician out and found that it was a broken ground wire. So it definitely saved some things. Then it also protects for situations of high voltage. If it goes above, I don't know, 129 volts, or if it goes down below like 112, 113, it'll shut off the power, just because lower high voltage, including a miswired one that's wired for 240 volts vice 220 or 120, is a recipe for disaster. High frequency, that just basically means the electrical system in the US is designed for 60 hertz. So the voltage, if you actually measured it with a really fast oscilloscope, you'd see the voltage goes up and down really fast. That's why they call it AC, or alternating current, and it happens 60 times a second. That's what your 60 hertz is about. Most equipment in the US is designed for 60 hertz systems, including what's in your RV. So if there was a problem with the park's electrical system or the power generation at the power plant, and this frequency was off, you could run a risk of damaging your thing. So it checks for that. So it checks for both low and high frequency. And then E10 means replace surge. That means this thing got hit pretty hard with a surge or something, and it became your fusible link, protecting your RV, so you probably have to replace the entire system. This has been a really good thing. Like I said, it saved me twice. Once the open ground that I encountered at one campground that I mentioned, and one time in the middle of summer we were camping, and it was relatively busy, and had the air conditioners on, and then all of a sudden it shut off the power to the RV. Went over and looked at it. So basically the power had dropped down to about 102 volts, and you run the risk of, especially high impedance things like air conditioners, they just don't tolerate low voltage very well. So I could have had a $1,000 or $2,000 repair bill had the air conditioner fried. So once again, it just, I think it saved me that thing. And at $300 to pay for something that gives you that measure of protection it's a very worthwhile thing. But anyway, so last couple years I've used this portable one. It's nice. It allows me to plug it in to any post. I added this cable lock right here just to secure it to the pole, just because theft is a potential. I just never really liked the fact that it just kind of stuck out and was on the post and everybody could see it. So I decided this year that I was going to upgrade to a hardwired version. So it just came in yesterday. So this is the box. You can see it looks very similar to this, except it's in a different form factor. It's got a cover held on by 6 screws. It's got this, and this is straight out of the packaging, it's got this telephone cord looking thing. That's to allow a remote monitor. So instead of having a monitor built into it, you can put the monitor anywhere you want within reason that the cord can reach. Plus it's built into the RV now, so you don't have to hook something else up. You don't have anything where people just see it and it becomes a chance for theft. So it just adds an extra measure of security. The other bonus is that it's actually a couple dollars cheaper than the all-in-one unit. So figured it was a good time maybe to switch them out. Hardwired the RV, so it's not something I have to worry about anymore. And came with some instructions, came with the cord, this little piece of cardboard, and then the cover is only held down with 2 of the 6 screws. So if you run the screws out real quick, you can see the cover pops off. There's a wiring diagram here on top, and then there's a couple things inside. There's some grounding screws, some wire lugs, some more black screws. So remember I said there were 6 screws. Only 2 of them are being used. Here is the open this thing up real quick. This I believe is there's your remote monitor, and it gives you an option. It's kind of interesting. You can actually bypass it or use it. So if there's a fault that keeps kicking and you know it's not real or whatnot, it gives you the option to bypass. You did not have it with the other one versus actually just removing it and plugging directly in. So kind of an interesting feature. And then right here in this other one, there's a no contact ammeter. So it's basically measuring the current so the electrical current going through the system. You run your wire through a magnetic pickup, and that's how it measures how much current your RV's pulling. So you'll know if you're at the limit. So if you have a 30 amp RV, if you see it's pulling 29, you know you're pretty much right at the limit of something, and you probably want to consider turning something off, so you just don't overheat any wiring in your RV before, or throw the breaker at the power pedestal. So with that being said, let me set up by the RV, and we'll figure out how to get this thing installed. So there's multiple ways you can install this system. You can do it to provide protection from shore power issues, just by wiring it back here in line with the cord coming out. You can do it after the transfer switch, which is if you have an onboard generator. That's the thing that will switch between shore power and generator power depending if which one's on, which one's not. If you put it in between the transfer switch and your electrical load center within your RV, where your fuse box would be, that would provide protection from both the generator and the shore power, but it makes for a little bit more of a difficult clean install, just because you probably have to put it in behind your fuse box. My transfer switch right over here, you can see it just leaves very little room. I mean, there is a wire coming in and out within conduit. I'd have to cut conduit and move things around, and it would be just a bit of a pain to do, I think. So I'm going to opt, since I do most of my camping on shore power and or battery, very little on generator, I'm going to go ahead and just do it on the one. And generally speaking, I don't think you'll have too many chances of electrical faults with a generator anyhow. So just to get oriented, right here is the power cord that goes up into the RV. There's a port over here on the side that you can pull it out so you can actually have the door closed. For the purposes of this installation, it doesn't make a lot of sense, and I don't need to do that. On my particular model, I have a inverter that's mounted here to the ceiling of this compartment. I've got my slide controller for the slide out back here, some other various wiring, and then, like I said, the automatic transfer relay. The way I'm going to approach this is I'm going to basically interrupt this cord, cut it at some point, mount the unit somewhere in here, and then basically have it come out of the cord. To one side of the cord will be on the in, and then the other side of the cord will be on the out. So then you're basically providing protection before it gets to the automatic transfer relay. So looking at the system, my best bet might be to install this. I might install the unit down here near the bottom. That way I can at least use some of these clamps that are still in here, just to provide strain relief for the cord. So let me start by, I'm going to loosen this cord up on the top here. Okay, so I've loosened the cord up. I think what I'm going to do is, there was a clamp here on the left side of the inverter. I'll keep that there, allow the cord to come down, maybe here to angle, use this as my input right here, and then basically have an output, and then have the cord come back up and then get secured by some of those loop clamps as well, just to provide the strain relief and prevent any damage. So, okay, just grab the unit. I think what I'm going to do is I'm going to mount it just basically here, up underneath the inverter, up on this back wall. After looking through the bags and whatnot, I noticed that this unit did not come with any mounting screws. So I just rummaged through and I found a couple like self-tapping screws here that'll work on this plastic liner. The other thing that I'd like to point out is there are two ground screws. They were in the baggie that I showed earlier. They're designed to basically come up here through the bottom. You can see I stuck them both through here, and then there's a nut. And when you run your output wire and your input wire, you want to make sure that the grounds of each get a lug mounted to them. There were some crimp-on lugs, but then they would get attached to these, and you can see there's a metal contact bar that goes all the way around, so everything is held in continuity. One thing I am going to do is I'm going to turn this thing somewhat upside down. This magnetic pickup belongs on the output wire, and since my power is going to be coming in here from the right, I need the input side here on the right. So that'll work. And then before I mount this thing, because of where these screws are, to make sure that I can get a wrench or a Phillips head screwdriver and a wrench on this to tighten it up, I'm not going to mount this thing until I have the wires roughly ran in place, and then get the grounds at least attached. That way I still have access to those things. What I'm going to do is I'm going to roughly orient where this wire was up on top, and then give it a small bend. The wires do need to be long enough when you cut it to make sure it can reach these two terminals here. So if I basically cut it roughly around here, I know I'll have enough left over. So I've got these loppers that I have. Give it a good snap. You can use a razor blade slowly, or you could work at it with some side cutters or whatnot. The main thing is just you just want to get it cut and out of the way, and not lose any of these. So the idea is you just want to get it cut and out of the way so you can start working on this. So the first thing I'm going to do is I'm going to measure this again, kind of figure out how much of this wire I need to strip back. So I'm going to give it using my razor blade, I'm just going to give it a slice down the length here, remove this sheathing. Okay, get rid of this filler material. So I've got this strip. You'll see it's this is a 30 amp unit, so you'll find it has a black, white, and a green. If you had a 50 amp unit, it's very similar. This will be an extra wire. You'll have a black, red, white, and green, because you'll basically have 220 volt legs that constitute your power. Use some wire strippers. Want to remove a little bit off the end of each of these wires. So I've got a nice clean strip here. A small little twist to get rid of any frayed wires. So for this one, I'm going to go ahead, I'm going to re-secure this clamp up here. Feed this wire up and through the end. Make sure the sheath is securely through the clamp. Not to have any okay. So the wires are now in. And if you look here, it makes it pretty simple, but you can see the whites are basically here on the bottom, the blacks here on the top. If this was rotated around, it would be opposite. So you want to make sure these things are placed in roughly the same or in the same orientation as the other side. So I'm going to loosen up this clamp here. Basically, you've got to run your black wire through the ammeter here. Kind of out of the way. That way you can measure the current that is flowing through your wires. There we go. Bend that up in there. So, and then same thing, the white wire you want to make sure this is loose. Push the white wire up in there. Then it came with these little ring terminals for the grounds, as I mentioned. Do this relatively tightly. And this wire was the hair. Slide the terminal on, and then using a set of crimpers. Give it a good squeeze. I like to give it just a quick tug, make sure it's nice and tight. Loosen up the screw. Place your terminal up over it and put the nut on. So that takes care of that one side. Basically, we're going to repeat the process for the other side. Only difference is there will not be an ammeter on this side, so you don't have to run a wire through anything. So all you need is a Phillips screwdriver to hold the top of the screw, and I checked, these are 3/8 inch nuts on them. I've got this fancy little screwdriver, works well in these little tight confines. I can hold it while I give these guys a tightening. Okay, so that wraps up that part. What I'm going to do now is I'm going to roughly put this in a position where I'd like to mount it. Now that I have it, I'll just start use one of these self-tapping screws, get the hole started so I can have something to line up against. We'll do the same thing here on the other side. Okay, so now everything's nice and secure. I think we're ready to give this thing a test before I close it up completely. Okay. All right, let me give it a plug in and see what we get. Okay, so I've just plugged it in. If you remember earlier when I showed my portable one, you can see It'll cycle through the different settings, and you can see it's showing 60 Hertz E0, which means normal conditions, about 127 volts. So I guess our power's a little extra saucy today. And about 2 amps pool. Like I said, it's probably just the converter and whatnot that was done. So seems like everything works as advertised. Let me go in the RV and just test out a couple things, and I'll be right back. All right, so I verified everything inside works as it should. I'm getting power to the microwave and some of the other appliances, so I know I'm getting good solid power through the system and it's not doing anything weird. So I'm going to put the cover back on. Yes, I do know it's going on upside down. I just want to make sure, if you recall, that I said I put it so my input side was here on the right, my output side's on the left. I want to make sure the labeling here on the cover matches how I have it done. So that wraps up the hard wiring part of the project. The only thing that's left is to figure out where I want to mount this monitor. Okay, so I looked over, didn't really find anywhere that I particularly wanted to have this unit inside. Plus, I didn't feel too keen in drilling a hole somewhere, trying to find where a wire was going through, because this thing isn't super long. So I'm just going to mount it up in here. So I'm just going to rebundle this telephone wire in little loops. And then what I'll do is I'll just wire tie this off here on the side with a couple zip ties. Zip tie looks like it'll work fine. So just cut the excess off, and this thing plugged in on the bottom. Like that. Put that around to the back side, and then I'll put the other screw in. Yeah. Okay, that's it. That's how you install one of these hardwired electrical management systems on a 30 amp rig. Like I said, a 50 amp rig would be pretty much the same, except you would have 2 of those inductive pickups and an extra wire both in and out, which will probably be red in color since you have 2 120 volt leads. So it's a good upgrade, an upgrade I recommend, whether you use a portable unit or a hard one like I just did. Feel free to check out my content on www.rvtricks.com. I do know I have an article, I'll post a link below it, that explains why I believe everybody needs one of these electrical management systems. Thank you for watching the video, and have a good day.